Hello everyone, myself Bharadwaj. In this video, I will show you how to do a foundation field bus based control valve calibration using heart communicator. See, this is a pneumatic control valve and the main parts are air filter regulator. This is the air filter regulator, valve positioner, actuator, valve stem, valve body. The instrument air is connected to the air filter regulator input. The output of air filter regulator, it will go and connect to the valve positioner. This is instrument air supply. Remember that. The valve positioner will receive the command from the DCS system, and as per the command, it will control the or regulate the instrument air supply to the actuator. The actuator receives this instrument air supply from the valve positioner and then moves the stem position as per the signal. Then you can control the valve open and close status as per your DCS signal. So this is the basic overview. Now to do this exercise, first I have to remove the top cover of this valve positioner. So first I will remove the top cover and then I will connect my heart communicator. You can see the tag name of this valve. It is 11FV1203 and this is valve stem. You can see it very clearly. You can see the orange color cable. This is foundation field bus cable connected to our valve positioner. This cable will be connected to a foundation field bus junction box, and from the junction box it will go to the DCS system. See, there are 4 screws are there. So first we have to remove the screws, and this is the internal part of valve positioner. And next we have to connect heart communicator across these terminals. Remember, your heart communicator must have a field bus license. Then only you can access, you can view the data, or you can do the configuration, you can do the calibration, or you can access the diagnostics from your heart communicator. This is a foundation field bus based device. So you must have a valid license in your heart communicator. The top cover of the valve positioner is removed and you can see the inside components of a valve positioner. And these are the 2 terminals, foundation field bus per cable terminals. Across these 2 terminals, we have to connect our heart communicator. So I'm using an extension wire here for connecting the heart communicator across these 2 terminals. These are positive and negative terminals. It is a 1 pair cable between valve positioner and your FF junction box. Okay. Now we are connecting the heart communicator across this valve positioner 2 terminals. Remember, you must check your polarities before connecting the heart communicator. After connecting the heart communicator also, you can change the polarities if required. Now the 2 terminals are connected across the valve positioner. So the heart communicator was connected across the 2 terminals of the valve positioner. In the next video, we will discuss about this heart communicator and its inside parameter. In this video, I will show you inside heart communicator. So this is our heart communicator. Using heart communicator, you can do the configuration of a device. It may be a heart-based instrument or foundation field bus based instrument. In this case, we are using a foundation field bus based device. So we have to go to the field bus menu. See, this is the default menu of a heart communicator. As we are using a foundation field bus based device, we have to go to the field bus menu. So let's see that, and I'll press enter. This is our field bus menu and we have to go to online. Wait for some time. Again, press enter. We have to go to online, and then we can see the available foundation field bus instruments on the network or on the segment. See, there is a warning. There could be a database mismatch. It is saying that there is a database mismatch between your host system database. It is fine. You can press S, no issue, and then it will go to the network. See, it will take some time. It is a acyclic communication. It is having the least priority. That means it will take time, depends on your number of devices, length of the cable, so many parameters. Okay. See, now this is live list. Okay. Field bus live device list. When you connect your hot communicator to any instrument, you can access or you can view all devices connected to the network. Remember, here network means the respective foundation field bus segment or foundation field bus junction box or foundation field bus trunk cable. Let's say there are 30 foundation field bus junction boxes. That means you have 30 networks, 30 segments. So when you connect your hot communicator to your field instrument, you can access the devices related to a single segment. Now we will see this hot communicator details. You can see the number of devices found 11, 1, 1. We have complete 11 instruments are connected to this junction box. You can see here LAS, link add to scheduler. So we know that our foundation field bus module or card is called as link add to scheduler. You can see this clearly ALF 111 4 14. ALF 111 is foundation field bus IO card in Yokogawa DCS systems. And remember, every device have a device address in foundation field bus. For this LAS, the device address is 20. Similarly, we have two LAS cards, right? We have two foundation field bus cards in our DCS system for backup purpose, for redundancy purpose. So the second card, you can see its number is ALF 111 4 15, the next one, and its address is 21. And now we are seeing the live list. Now I will show you all the instruments connected to this network, and you can see the tag name of the instrument and the device address. Okay, this is a flow transmitter, flow valve, flow transmitter again, level transmitter, temperature transmitter, pressure transmitter. Okay, and you can see the device address also, the node address or device address. So level transmitter, temperature transmitter, PT, TT, and then field communicator. So I connected my hot communicator to the segment. So this hot communicator also have some temporary node address. The link add to scheduler will assign a temporary node address or device address to a hot communicator. In this case, it is 252 is a temporary address assigned by the link add to scheduler. Okay, for my hot communicator. And again, I will show you all my instruments connected in the junction box. Remember, you can access any device from this list. You can enter and you can view all the configurations. You can see diagnostic messages, or you can do the calibration of any instrument by connecting to any instrument on a foundation field bus segment. What is the tag name of my control valve? It is 11FV1203. The device address is 23. For this control valve, I want to do the calibration now. But remember, by connecting your hot communicator in a segment at any place, at any instrument, you can access all instruments parameters. You can view the diagnostics, you can change the configuration parameters, or you can view the configuration parameters. Okay, you can do anything at any place. Next, I will press enter, and then it will go to the 11FB1203. I'm pressing enter. Again, it will take time. See, uploading a reading status. It will take time. Foundation field bus for acyclic communication. It may take time. You have to wait. See, let's see how much time it will take to enter into the device so that we can see the configuration parameters or we can view the diagnostics. Loading complete. The time may vary. It is not like every time it is delayed. See, the time may vary. It depends on your network. It depends on your segment healthiness status also, or number of devices connected to your segment and its physical properties like cable length. Okay, we have to wait. See, still taking time. We almost entered into the configuration settings. See, now we are inside the 11FV1203. This is a Mezzo valve positioner. Inside your field bus settings, you will find different blocks like resource block, transducer block, analog input block, analog output, digital input, digital output, PID, etc. In this case, this is the analog output, right? It is using a digital communication, but the block names we are calling as analog input, analog output, okay, based on the type of instrument. It doesn't mean that we are using a 420 milliamp signal. We are using only digital communication between your foundation field bus instrument and DCS system. Thank you. I will meet you in the next video. So let's see the blocks inside the foundation field bus parameters. The first one is resource block, transducer block. Okay, we will see the all blocks here. What is the tag name of our instrument? 11FV1203. This is assigned to a analog output block. For control valves, it is a analog output. That is why the block type is analog output here, and the block tag is 11FP1203. If it is a flow transmitter, then we will use analog input block. Okay, this is only resembling the type of instrument. We are using digital communication between your field device and DCS system. Let's see the available blocks in this positioner, and this is entered into the resource block right now. And in resource block, we will have the all parameters related to your valve positioner, the manufacturer ID, device type, model, your device revision, your DD file version, device description file is very important. Now let's see the block types: AI, AO, DI, DI, and DO, PID. This is input select, output select. Okay, fine. So these are the blocks available in this positioner. Okay. Remember, each block have mode. In foundation field bus, whenever you are using a block, then you have to put that mode in auto mode or cascade mode. If you are not using a block, then you have to put that block in OOS, out of service. In this valve positioner, we are using only AO, block type AO. This is a analog output instrument. That is why this AO block is enabled. For valve positioner, we usually put this block in cascade. Other blocks we will put in auto mode. If you are not using a block, we have to put in out of service. You can see the PID we are not using here, out of service. Block type DO, digital output we are not using, out of service. In my case, I don't have any requirement. That is why I'm not using. If you have a requirement, you can use these blocks also, no issue. Now I will go to the custom. I need to go to the transducer block to do the calibration. See, this is a transducer block. Here you can see different menu items, and then I have to go to the calibration for doing the automatic calibration. So I will go to calibration and press enter. I am using the arrows here, up arrow, down arrow, left and right, so that for the navigation I can do it inside the communicator. Okay, and then I will go to the automatic calibration. I will press enter. Right now the calibration command is idle. We are not using any calibration. Now I will change this command. See, I will press enter again. Again I will press enter, and I will touch here. I will see the available commands. See, these are the options available for the calibration. Start automatic travel calibration and position feedback also included. Second one, only travel calibration. The third one, position control tuning, 1 point calibration, etc. I want to do the automatic travel calibration and position control tuning, so that calibration will be completed with feedback adjustment. Okay. So I had to select that first one, start automatic travel calibration and position, and then I had to press OK, and I had to press send. See, one error came. What is the error? Wrong mode for request. Whenever you're doing some work in foundation field bus, you have to put that respective block in out of service. That is why the command is not accepting right now. Now I have to press the mode. Now I have to remove the auto mode, and I have to select out of service. Now I will remove the auto mode, and I will select only out of service, because right now I'm doing the calibration and this device or control valve is not available for the operation. Okay, and press OK. Click yes and press send again, send button. Now it will take the command, calibration will be started. See, the automated travel calibration is started. Now the valve will move automatically between predefined stem positions, and the position feedback also adjusted. The valve positioner algorithm, now it will start and it will check for different points. See the cal means calibration. It is at 5. It has to reach 100 to complete the calibration. It will take some time, 2 minutes to 5 minutes. Okay, depends on your design. The valve will automatically travel. There is no need to do anything now. We have to wait for some time. You can see the status on the display also, or on your hot communicator. This is our valve positioner display. Remember, you can do the calibration from your display also without connecting the hot communicator. But in this case, I want to show you the hot communicator. That is why I'm doing it from the hot communicator. Right now, the status is 44. It will reach 100. Until then, we have to wait. Meanwhile, you can see the valve stem position also. It will move, and the status also will be updated on your hot communicator. Remember, whenever you put the block in out of service, the DCS will not control this valve. Even if the DCS gives some signal to the control valve, it will not operate. So you must put this block in auto mode, then only the DCS can control the valve. See, the calibration is still running. There are no errors right now. What type of calibration is going on? Automatic calibration plus position feedback adjustment. Now the status is 60. 60% is completed. We have to wait till 100%. So these are the pressure gauges. You can see the input and output pressures also here during the calibration. You can also see this knob. The knob will move so that you can understand the valve open or close status. Now it is at 65%. 71 percentage, 75. In foundation field bus, you have to understand the block names and which blocks we use for the configuration of a control valve or a transmitter. For transmitter, we use AI block. For valve, we use AO block. Resource block and transducer block are common. Now we reach 90 percentage. You can see the knob status also. Based on that also, you can see the open or closed status of a control valve. 95 percentage. See, the calibration is completed. You can find the successful message. See, successful on the display. Calibration is completed. You can see the same status on your heart communicator also. Now we will see the same status on your heart communicator. This is a successful calibration. See, the calibration was successful, indicates no error. Okay, calibration was successful. Remember, our job is completed, but we have to put the mode again in auto mode. We have to remove the out of service because our job is completed. I have to press mode again and select out auto and deselect out of service OOS. Okay, yes, that's it. The calibration is completed. The calibration is completed. So we have to remove the heart communicator and again we have to cover the valve positioner. The job is completed. This is how you can do the control valve calibration using your heart communicator. Remember, it takes time for a foundation field bus based device. For doing the control valve calibration, we usually do with the valve display because it is very easy and fast. If you don't have a display, then you can do it with your heart communicator or you can do it from your control room also if you have a plant resource manager in your Yokogawa DCS system. Thank you. Please like our videos and share our courses with your friends and colleagues.